Alrighty, everybody. So we're going to keep going with this law of signs, but now we're going to talk about a little bit different scenario when we look through these. So for 5-7, it's something called law of signs, the ambiguous case. I'd like you to look up, Google the word ambiguous for yourself here really quick. So pause the video if you need to. Go ahead and Google the word ambiguous, see what it says, then we'll check back in. Okay, so if you Googled it, it says that ambiguous means that the solution is open to interpretation. It's unclear, and that's exactly what we're going to be looking at today. The information we know about the triangle may not be clear right away to be able to tell how many triangles you actually can draw. So remember, we're solving triangles that are not right triangles, so no SOHCAHTOA, no Pythagorean theorem. They don't have right angles in them for our given information, what we know about them. So we have different kinds of things that we can know about the triangle, though, to be able to solve. So what we did from before in 5-6, I kind of have them written out here, is where you know two angles and a side. So you know two angle measurements and then any side. Okay, if you know two angles, though, you really know all three, right? Because you can subtract from 180 and find that, and then you can find everything you need to from law of signs. It works out really well. What we're going to talk about that's new in this section today is what happens if you know instead two side lengths and the measure of an angle. Okay, well then we have a whole different ball game about what can happen. So we'll talk about that ambiguity or that unclearness, that openness in just a second. I want to start though with a review of one of these 5-6 questions just to make sure we remember what we were talking about from before. So if you know this two angles and a side, and I'm going to add in the word opposite up here. So two angles and a side that is opposite the angle that's given. Doesn't always have to be opposite to start with, but ultimately you will be able to find the side that's opposite or the angle that's opposite, because if you know two angles, again, we're going to be able to find that third one. So we're going to end up having an opposite side no matter what. Okay, well, if you know two angles, first thing you do is you find the third angle and then use law of signs to find the other two sides. So that's exactly what we're going to do. So this is review. This is what we did from before. And I'll have you pause the video to do some calculations. So it says solve the triangle. That means find all the pieces. So I'm given two angles. How do I know? Well, look in your picture here. We know angle A, angle B. So first thing you can do is find angle C. We're going to subtract those two from 180 and we get our angle C. So go ahead and do the calculations along with me here. I think that's 133.8 if I'm remembering my arithmetic correctly. Okay, so I have my angle C. Now I know everything about the angles. I can solve for the side. So we'll set up our proportions in law of signs. Little a is the sine of angle A, 27.7, as the thing I know everything about is C. 50 is the sine of angle C, which is the angle we just calculated, 133.8. Remember, to solve these, we cross multiply and divide. I'm going to write the work. What I'm writing right now, you would never really have to show. You can just do it on your calculator. 50 times the sine of 27.7 divided by the sine of 133.8. And go ahead and pause the video each time here and do your calculations so you have your numbers. So for little a, for me, that ended up to be 32.2. Make sure you type them in. Don't just assume it's going to work. That usually comes out badly in the end. Make sure you try it yourself. All right, little b is the sine of angle B. That's the 18.5. As we're going to go back to the given information. So 50 is to the sine of 133.8. degrees, cross multiply divide. Again, what I'm writing right now, I would never expect that you would have to show. It's just what you're typing into your calculator so you know. So 50 times the sine of 18.5 divided by the sine of 133.8. And our little b, go ahead, pause the video, type it in. Little b ends up to be 22. All right, now, when you look at this for reasonableness factor, our side C should be the longest because it's across from the biggest angle. So that checks out. 50 is definitely the biggest. Angle A is the next biggest angle, 27.7. It's across from 32.2. Fantastic. And then little b is 22. It's the smallest side. So that works out great. Okay, so that's what we did before. That's two angles and a side. Now we're going to switch gears. We're going to talk about the ambiguous case. So now we're really going to get into 5-7 here. So 5-7 is when you know two sides and an angle. So side, side, angle. So that's the given information, two sides and an angle. What can happen then is you can have no triangle at all, maybe one, maybe 2. It depends. So when you're looking at the information you have, we have to do a little digging to be able to figure it out. That's why they call it ambiguous. It's unclear. It's open a little bit from the beginning. So what we're going to do is we're going to go ahead and figure out first from the given information, looking at the angle and the side across from it, what do we know about the triangle? What kinds of solutions can we have? And then we'll be able to solve using law of sines. Okay, so I have this picture that we're going to use. This is what we're going to be going back to. So make sure you make some notes on this so you know. I'm going to put a big line down the middle here to separate our case 1 and case 2. The difference between these possible triangles is the size of the angle that you're given. So let's talk about what they're always going to be giving you here. All right, so what you're going to be given, this is really important, is 2 lowercase letters and an uppercase letter. Now, the 2 lowercase letters are sides then. So you know 2 sides and you know an angle that's opposite. So you're given 2 sides and 1 angle that is opposite. I know this is kind of a duh question, but the angle is opposite because it has the same letter. So capital letter A, lowercase letter a. Now, I don't want you to get hung up on the letters though. These don't have to be A and B. They could be P and Q. They could be L and M. They could be D and F. It doesn't matter. It just matters that you're given 2 sides and an angle that's opposite. So look for the labeling that is the same. Or if there's no labels at all, you're going to have to put labels on them. So just make sure you know it's 2 sides and an angle that's opposite. Okay, how do you know the difference between this case 1 and case 2? It depends on what the angle is. So if the angle is acute versus if the angle is right or obtuse. So if the angle is less than 90 degrees, or if it is greater than or equal to 90 degrees. Now, I'm going to talk about case 2 first, because the greater than or equal to 90 is a lot easier for people to figure out. If the angle that you're given is greater than or equal to 90, would you agree then that that's the biggest angle in the triangle? Absolutely, it has the cross from the longest side then, right? So if you have the biggest angle in the triangle, it has to be across from the longest leg of the triangle. So if this is going to work, if you're going to be able to draw the triangle that they're talking about, that means the side that you're given, whatever letter it is, that's across from the angle you're given is going to have to be the longest. Okay, well, here's the 2 possibilities then. If that side A in this case, because I'm given angle A, if that side A is shorter or equal, there's no triangle. It has to be the longest leg, so it's physically impossible to draw it. If that side A is bigger, there's 1 triangle, then it actually works. You can actually draw it. It will be an obtuse triangle, and you're going to be able to solve for those other pieces by using law of sines. So in case 2, it's as basic as just comparing the sides. If it's longer, cool, 1 triangle. If the side opposite is shorter, can't do it. It's physically impossible to draw. It'd be no solution. Okay, now I'm going to have you on this other side, case 1, when the angle you're given is acute. I'm going to have you bubble these 3 together because these 3 kind of go together. And then we have our other situation. The 3 that I just had you bubble is when the side opposite the angle you're given is shorter. We're going back to that same scenario that we did with case 2. If the side opposite is shorter, we have issues we have to deal with. If the side opposite is longer, just like in case 2, we have 1 triangle. It works out really well. Actually, I'll circle that in red so you can see that a little bit easier. So 1 triangle. So if the side opposite in this acute situation as well, if it's longer, there's only one way you can draw that triangle. This side A, it's longer than B. So the only thing you can do when you draw the triangle is draw it going away from your angle A. If you try to draw this side A, which is longer, coming back, it's not going to make a triangle. It's going to cross over that B side. It doesn't work. You can't draw that. It doesn't physically make a triangle. So if it's longer, there's only one way you can draw it. Works out great. So that's not so bad. It's this what if it's shorter situation. Okay, well, if it's shorter, if the side that you're given across from the angle is shorter than the other side that they give you, there's 3 possibilities. It's either none, 1, or 2 triangles. And how you tell is just by finding that first angle. You set up law of sines and you solve. If the angle that you are solving for, so in this case it's angle B, right? Because they're giving you little a, little b. It may not be angle B though, depending on your letters. If you end up getting an error, if your calculator says error, that means it's physically impossible to draw. This little side A, it's too short. It doesn't actually make a triangle. All right, how do you get 1 triangle? It means if you end up with this kind of an angle. If your angle B, when you solve for it, ends up to be 90 degrees, it's 1 triangle. There's only one way to draw a right triangle. Draw a right triangle, drop the perpendicular. Here's the situation that gets a little bit crazy. The way that you end up having 2 triangles is if your angle B is any other angle measurement other than 90. So any other angle, it could be 27, 58, 76, whatever. If it's any other triangle or any other angle, you're going to have two triangles. You're going to have one that's acute and one that's obtuse. And we'll talk about in this day 2 part of this how you actually find them. But basically it has to do with whether you go away from angle A, or that would make the acute triangle, or back towards angle A, which would make the obtuse. So we're going to talk about very specifically in the part 2 of how do you actually find those. So those are the scenarios you have. There are really 6 different possibilities that can happen, but we're going to sort them by what the angle is. And we always compare the side across from the angle to the other side we know to see what's going to happen. All right, so let's start with the case ones. We'll kind of dig through this more situation, the more ambiguous part here. Case 1, remember, is the angle that you're given is acute. So the angle that we have, the measure of the angle, and I'll just call it A because that's what the book is using here, is acute. So I guess I'll just say that. Measure of angle A is acute. So if the angle that you're given that is opposite the side is acute, that's case 1. All right, so there's either none, 1, or 2 solutions in a case 1. So none, 1, or 2. In order to be able to check and know, the only thing you can do to start off with here is use the law of sines to find that first angle. So we're going to check and see what happens in that first angle. Then we'll be able to tell if it's none, 1, or 2. Okay, so let's kind of plow into this here. All right, so take a look at what you're given. We're really going to spend a lot of time on how do I know I'm using law of sines. So first of all, identify what you know. How many sides do you have in this first example? Well, 2 lowercase letters, so I'm given 2 sides. All right, how many angles did I give you? 1 uppercase, so there's 1 angle. And is that angle opposite one of the sides that I gave you? Well, it's angle A, and I have side A, so it is opposite. So that's important. That means those 2 pieces together means I'm going to use law of sines. I have an angle and a side opposite. I can do law of sines. Okay, what kind of angle is it? It's 30 degrees. It's acute. What does that tell me? That means I'm a case 1. Now, case 1 and case 2 are labels that I've put on these to help us talk about it. What matters is that the angle you know is acute. That's what we need to be able to tell. That means we have all those different ambiguous situations. Okay, so what do we have to do? Well, we have to figure out, is the side across from the angle longer or shorter than the other side we're given? So which number is across from the 30-degree angle? Well, that would be this one, the 3. Notice I'm avoiding the labels because the labels can change. But in this case, it's side A, but it's the angle or the side that's across from angle A, or the side or the angle that you're given. So the 3 is less than 8. Right? So the 2 sides that they gave me were 3 and 8. 3 is the one that's across from the angle. It's shorter. What does that tell me? I'm going to go back to my pictures here. If it's shorter, that means we're in this green bubble over here. So we're in this situation where A is less than or equal to B. It's going to be none, 1, or 2. Okay, how do I know if it's going to be none, 1, or 2? So I know it's one of these 3 possibilities. I just don't know which one yet. Well, you have to find that first angle that you can solve for and see what happens. See if you get error, 90, or some other angle. So I'm going to go ahead and set up law of sines. So 8 is to the sine of angle B, as 3 is to the sine of 30. Now this one I'm going to show the work for again because this is a little different. I'm not solving for sides anymore. Now I'm solving for an angle measurement. So when we cross multiply and divide, we have one extra step we need to deal with. So let's do that. So 8 times the sine of 30 degrees is equal to 3 times the sine of angle B. Divide by 3. So I get sine of angle B is equal to 8 times the sine of 30 degrees divided by 3. So here's where it's different. Normally we just cross multiply divide when you're solving for a side. Now I have this sine of angle B that's left. I don't want sine of angle B. That's not what I want. I want just B. So what you have to do is take the inverse sine on each side. Remember, we do the opposite operation. We take the inverse sine. So sine, inverse sine, those are opposite operations. They cancel out. When we do the inverse sine on the other side, see what happens. So pause the video, type it in, make sure you have your parentheses and all that. Pause, see what you come up with. Okay, so what you should have gotten, I know this freaks you out a little bit, you should have gotten an error message. What error message means is that when you go back to your pictures, it is physically impossible to draw this triangle. We are right here. Error, that means there is no triangle. You can't physically draw it. This little side that they gave us, this measure for that A, it's too short. So when you get this, that means it is no triangle. There is no solution. It's physically impossible to draw. So it was a case 1. The side opposite was shorter, so I knew it was none, 1, or 2. How did I figure out it was none? I set up and solved for that first one, I got an error. All right, so let's take it to the next one here. We just want to keep walking through these. Take a look at what you know. Always look at your given information. They gave you two sides, one angle, and is the angle opposite? Well, sure, letters are the same, so it's opposite. And what kind of angle is it? It's acute. So what that tells me is it's case 1 for law of sines. So I know it's law of sines because the angle is opposite. I know it's case 1 because it's acute. And now we compare. We always compare the sides. No matter what case we're talking about, you always compare the two sides you're given. So which number side is across from the 30-degree angle? Well, that's the 4. Same letter, right? And compare that to the 8. It is less than again. We're in the same boat we were the last time. 4 is less than 8. That means it's none, 1, or 2 triangles. It's got to be one of those 3. So we're back in this green bubble over here in our pictures. How do you figure out if it's none, 1, or 2? You do law of sines. We find that first angle that we can solve for, which in this case happens to be B, and then we see what happens. So 8 is to the sine of angle B, as 4 is to the sine of 30. I'm going to go ahead and have you pause the video, cross multiply, divide, take the inverse, see what happens. So when we type this in, you're going to end up doing the inverse sine of 8 times the sine of 30 degrees divided by 4. And when you do that, you should have gotten 90 degrees. All right, what does that tell you? If you got 90 degrees, go back to your pictures. That means we're right here in the one triangle category. We got 90 degrees. That means there's only one way to draw that. So for this one, that means there would be one triangle. Now, we're not going to actually solve for it today. We'll do that on the part 2. But for today, just, okay, what does that mean then? Could we find the rest of the solution? Well, what don't we know? We don't know angle C, and we don't know little c. Well, if you know angle A and angle B, we should be able to find angle C, right? Subtract from 180, and then to find little c, we're going to use law of sines. We'll do that in the part 2 video. We'll go back and actually solve these. All I want you to be able to do for today is know how many solutions were there. All right, let's try another one. All right, so tell me what you know about this triangle. Look at the given information, and it looks like, this is what we're being given. Looks like we know two sides again. We know one angle, and is the angle opposite? Sure, same letter. And it's acute again. 28 degrees, so that means we're in case 1 again. So we have lots of different case 1 situations to look at. But in this one, find the angle or the side that's opposite the angle. So the side that's opposite the angle is this number. And compare that to the other side that you're given. Notice I'm avoiding using the letters, but in this case it's the A and the B. The side opposite the angle is bigger than the other side that you're given. Look back at your pictures. We're in case 1 over here, but if the side opposite is bigger, we're down here in this 4th picture. That's so great because that means there's only one way you can draw that triangle. If that side opposite is longer, it can only go one direction. We can't go back the other way. All right, what does that tell me? That means there's one triangle. I don't have to do anything else. I don't actually even have to do the proportion because I know if it's longer, it's going to be one triangle. So the first thing you'd be solving for, and this is what we'll start with tomorrow, is, or the next part 2, I guess. It'll be tomorrow for me. So 20 over sine of angle B, 50 over sine of 28, and you can solve for that first piece. So we can do that, can find angle B, then we'll be able to subtract from 180, find angle C, and then do law of sines to find little c. So it's awesome. We know that there's going to be one because the side opposite was bigger. You don't have to do anything else. So we could stop right here. We know there's one triangle because it's longer. Okay, one more deal for case 1, then we'll go on to case 2. So if you can skip ahead. Oh no, I guess it's not ahead yet. It's just the next one. Then we'll skip the next couple slides. All right, so take a look. Take a look at what you know. So here's what you're given. So we know two sides again, and one angle that is opposite. So that means you can use law of sines. That's what this tells me. This is a law of sines situation because we will have a law of cosines eventually, so we need to know the difference. And then the angle that we're given is acute, 63 degrees. So that tells me in law of sines, I'm dealing with the case 1. And that's my number that I've assigned to it, so we have something to talk about. Okay, after you figure out it's case 1, there's always the next step is comparing the sides. So what is the number of the side that's opposite the angle? That would be the 17, same letter, and then compare that to the 18. It is smaller again. So now if you go back to your pictures, so if you think about the pictures that we were dealing with here, if it's smaller, we're in this green bubble again. So we're in the green bubble. The A is less than or B. So now I have to just solve for that first one, see what happens, and then I'll know what kind of situation I have. So I know it's none, one, or two triangles. I've got to figure out which one by doing law of sines. All right, so we'll start with 18 is to the sine of angle B, as 17 is to the sine of 63. Cross multiply, divide, take the inverse. Go ahead, do that on your calculator. Pause the video here for a second. So inverse sine of 18 times the sine of 63 divided by 17. So go ahead, cross multiply, divide, take the inverse. Remember, you're solving for an angle, and see what you get. So pause and go ahead and try that. And I came up with 70.6 degrees. All right, now what does that tell me? Well, I didn't get error, which means it would be no triangle. I didn't get 90 degrees, which means it would be one triangle. I got something else, so I got some other angle. What that tells me is this one is going to be two triangles. I know it's going to be two because I didn't get error 90. Now let's just talk through. Again, we'll do this on part 2 video. How would we solve? Well, we know for this set of solutions, I can find angle C then, right? Because I know A and B, so I can find angle C, subtract from 180, and then I can find little c using law of sines. Now, where does the second set of solutions come from? Well, this first set would be the acute triangle. That's what that would generate. The acute triangle solutions, we would need to find the obtuse triangle solutions, and it comes from finding the supplement of this angle right here, the 70.6. You remember how to find a supplement? Supplementary means that the two angles add up to 180. So supplementary, if you want to find the supplement of that, that's what generates the second set of solutions, because the supplement of 70.6 would be an obtuse angle that would give you the obtuse triangle version. So that's where that second set is going to come from. So tomorrow we'll talk about that. We'll look at those pictures and make sure we know how to solve. Okay, let's talk about case 2. That's so much easier. So case 1, when the side is less, then we have a lot more to talk about in the acute triangle situation. If it's obtuse, so much easier. So two sides and obtuse are right angle. That means the angle that you're given is greater than or equal to 90 degrees. So much easier because that means the side opposite has to be the longest. So that means there's either no solution or one solution. Either the side opposite is bigger or it isn't. So we use law of sines, we solve when we're doing the solving part, but the first step is just, does it even make sense to try it? All right, so let's take a look at what we know again. So you're still talking about sides and angles here. So you're given two sides, and you have one angle, and is the angle opposite? Sure, same letter. It's really important. That means it's law of sines. But now the angle that you're given is obtuse. So we have a little bit different scenario. That means we have a case 2, and that's the word that I've assigned to it. But obtuse is the kind of angle. So we still compare the sides. It's no different. We need to make this comparison. Which number is across from the angle you're given? Well, it would be the 6 because that has the same letter. They happen to be A in this one. So compare that 6, the side that's opposite, to the other side that you're given. It's less. Think about that for a second. Can the side opposite a 120 degree angle in the triangle be smaller? Well, no, because that has to be the biggest angle. So what does that tell you? That means there's no triangle. You cannot do this. It's no solution. It's physically impossible to be able to draw that picture. All right, let's try one more of this case 2. So we have two sides again. We have one angle that is opposite, and that angle that you're given is obtuse. So that means we're back in this case 2 again. So we know it's law of sines case 2. And we compare our sides. So what is the side that's opposite the angle you're given? That would be in this case A, which is the 22. Compare it to the other side that you know. It's bigger. Cool. Should the side opposite the obtuse angle be bigger? Well, absolutely, because it's the longest side, biggest angle. That means we're going to have one set of solutions, one triangle that we'll be able to draw. So being able to understand how many solutions you have is so important. So case 1, that's where your angle is acute. Case 2, it's when it's right or obtuse. From there, we compare the sides always. Is it greater than or less than? That tells us what realm we're going to be in. So we compare the sides, and then we see how many triangles we have. So that's our part 1. For part 2, we'll actually go back now and solve and find all the pieces that we need to. That's using the law of sines then. So day 1 assignment, just identifying, and then some review questions.